We're now going to be looking at exponents, and the first chapter here is just the definition of exponents, and then kind of using exponents as we simplify expressions, which you might not know what that means right now, but we'll see in a couple of examples. Basically, it just means using Bedmas to simplify things, and exponents are definitely a part of that. So let us just write down here, fill out the table. And so the easiest way to go about this is just to do examples. The base is the large number on the bottom, and the exponent is the smaller number in the top. Now this says 5 squared, and what that actually means is 5 times 5. Now I'm going to use a dot as opposed to an X. So 5 times 5. And we need to evaluate that. So 5 times 5 is 25. Now you compare that to the second one, where the second one, the base is 2, because that's the big number, and the exponent, the small number, in the top is 5. And that means that we're going to have 2 5 times. So 2 times 2 times 2 times 2 times 2. And that is 2 times 2 is 4, times 2 is 8, 16, 32. So that evaluates to 32. So exponents essentially, for the most part, until they're not, essentially is repeated multiplication. So that's for basically what it is for grade 9 here. Now, 3 to the power of 4. Our base is 3. The exponent is 4. That means 3 times 3 times 3 times 3. 3 4 times. Now, 3 times 3 is 9, times 3 is 27, times 3 is 81. Here, the base is 10. The exponent is 3. That means we've got 10 3 times, so 10 times 10 times 10, which is 1, and then there's 1, 2, 3 zeros. 1, 2, 3, so that's 1,000. Now, we need to keep in mind the negatives. So let's take a look at comparing this and this. Both of those, they're almost identical, but the first one there has some brackets. So our base for this, our base is whatever is attached to the exponent. So the exponent is attached to the 4 and to the negative. So the base here is negative 4. Here, the 2 is only attached to the 4, so the base is 4. If I wanted it to be attached to the negative as well, I would have done it like this. So if I put brackets around it, okay, well then that means that the negative symbol, it must be included as part of my base. Here in the second one, that is not true. I did not put any brackets, so the base is only 4. There just happens to be a negative out in front. The exponent for both of those is 2. So what does that look like? Well, this question right here, this first one, we have to do the base 2 times. So negative 4 times negative 4. And here, in this one, we have to do the base 2 times as well, but the base is just 4 times 4. And then we can just have the negative out in front. So that does change things for us. In the second one here, in the first one here, negative 4 times negative 4 is 16, positive, because a negative times a negative is a positive. And in this one, we've got 4 times 4 is 16, but then we have to remember that there's this negative symbol right here as well. So 4 times 4 is 16, but then it has to be negative because there's one negative. So you always look at the base, and the base is always going to be the thing that's in brackets. And if there are no brackets, then it's just the number that's attached. So for all of these, it was just the 5. It was just the 2. It was just the 3. It was just the 10. So down here, it's just the 4. If I wanted to do the negative, I would have done up here, where I wanted you to include the 4 and the negative. All right, so this one has brackets. The base is whatever's in the brackets, so just a 4. And the exponent is a 2. So what does that look like? Well, it does the base 2 times. So there's the base 2 times, and there happens to be a negative out in front, so I'll do that. And this is a 4 times 4, which is 16, and there's a negative there, so it's a negative 16. So let's take a look at all of these. The base was right there because there was brackets. There's no brackets, so it's just the number. There is brackets, so it's whatever's inside. Here, there's brackets, so it's whatever's inside. So the base is -4, and we're doing that to the power of 2, so we're doing that 4 times. So we're doing the base, we're doing that 2 times, and there happens to be a negative out in front. So how many negatives is that? There's 1, 2, 3. So the answer is 16, and then there's 3 negatives, and that's an odd number, so we have a negative, because 2 of them will become a positive. Here, the base, it tells you it's in brackets. So, okay, whatever's in the brackets, -2. And to the power of 3, so I want to do -2 3 times. -2 times -2 times -2. That is going to be, well, 2 times 2 times 2 is 8, and there's 3 negatives. An odd number of negatives is a negative, because 2 of them will cancel out and become positive, and there's only 1 remaining. Keep going here. There's no brackets around it, so it's just whatever's in front. It's just a 2 to the power of 3, so it's just 2 3 times. 2 times 2 times 2. And then there's that negative out in front, so we'll just attach that negative out there. 2 times 2 times 2 is 8, and then there's the negative, so we'll have -8. Now here, the base is 1, and we do that 100 times. So we go 1 times 1 times 1 times 1, and we're going to have to do that 100 times. So usually we just put dot, 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 times 1. Now, I would normally panic whenever there's 100 things being multiplied, but 1 times 1 times 1 times 1, it's always going to be 1. So 1 times 1 times 1 100 times, still 1. Here we have a negative. So it's in brackets, so that our base is -1, and we have 100. So we have -1 times -1 times -1, dot, 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 times -1. Well, all of the 1s multiplied will still be 1, but we have how many negatives? Well, we have 100 negatives. And that's an even number. That's even. An even number of negatives will become a positive. So the answer is just +1, or just 1. Here, it has brackets, so whatever's in the bracket is the base. In that case, it's -1. And we got to do that 101 times. So we have -1 times -1 times -1 times dot, 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 times -1. And so all of the 1s, 1 times 1 times 1 is still 1. But here we have 101 negative symbols. There's 101 of these. And that's an odd number. And whenever you have an odd number of negatives, your answer is negative. So our answer here must have been -1. And then here we go again. We've got no brackets, so it's just the number. So it's just 1 is our base, and we do that 100 times. So we have 1 times 1 times 1 times 1, dot, 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 dot. We do that so many times, and there's a negative sitting out front. So we'll add our negative out in front. So 1 times 1 times 1 times 1 times 1 is still going to be 1, even though we do it 100 times. And there is a negative that is just sitting out front, only 1 negative, so our answer stays negative. Now I got something in brackets, so that's 0. So I'm going to put 0 to the power of 5. The exponent is 5, so I have 0 5 times. Now 0 times 0 times 0 times 0, all of those zeros is just going to be 0. Now I've got a base of 100, and I do that 0 times. So I need to write 100 times 100. I got to write that 0 times, which is impossible. I can't write 100 0 times. And that's a trick question. And the answer to that is very strange. The answer is 1. And so you might want to make a little note to yourself here. Any number we choose, so any number to the power of 0, will always equal 1. And that's just a definition that you're going to have to remember. So 100 to the 0, 1. 50 to the 0, 1. A million to the 0, also 1. Okay, lastly here, we want to write these as we have a mixed basis, but we want to write them and make them a little bit more condensed. So I've got 2 times. I've got 3, and I have 3 of them. And then I have 4, and I have 3 of those. And so that is my simplified version. Here I've got 6. They're all being multiplied, so I got 4 of those. And then I have 7, and I got 2 of those. And it's nice to kind of put a dot in between, but you don't have to. One of the ways you could do it is the way that they've done it there, which is brackets. So I'll follow their lead, and they put brackets, so I'll do brackets. And here we've got 2. And here I'll put 2, there's 4 of them. I'll put the 4 on the outside. So you can have 2 4 times. In fact, this should probably be like that as well. I'm going to have 6, and I'm going to have 4 of them, and I'm going to have 7 and 2 of them. So here I'm going to have 2, and I'm going to put brackets there, and I put a 4 on the outside. And I've got 3's in brackets, and I have 3 of them. And I have -4 in brackets, and how many of those? I have 3 of those. And so those would be my answers. So I'll zoom out here. And I don't know, this is not going to work perfectly. Luckily, you can take a look at the answer key online. But I'll leave it like that, and we'll move on to the next ones.